Hi, it's Mr. Wyman. I'm going to go over the answers to our lemonade line plot assessment. I have a video that um, provides me reading the story that goes behind this, but today I want to actually walk you through what should have been done to answer these questions and some of the correct answers. The first thing you want to do whenever working on a math problem is try to figure out what this problem is all about. Well, this problem is all about lemonade and line plots. A few of you didn't even make a line plot, which was surprising. But here is the story. I read the story to you in another video, so I'm not going to do that now. But at the very end of the story is this data. Now, the story is all about two people, two kids running a lemonade stand and selling lemonade. This right here is the data that you're going to use in order to answer the problem, the questions. There's several questions that have to do with the lemonade stand and what happened. What is this? The second thing you want to do when working on a math problem is figure out what is it asking of you? What is the problem? Well, the problem in this case is the $1.25 per cup of lemonade, okay? And there are several questions that go along with this problem, and we're going to work on answering those questions right now. So I'm in Sketches School. I want to go over to my math folder that I've created, and I'm going to insert that image that I just took, camera photos, and then I can start working on it. All right, now here is all of that data again, right? And here are the questions, okay? So let's take a look at these questions, and we're going to go one by one, and what I'm going to do, here's a good strategy for us. I'm going to actually cross them off as I complete them. So the first one is fill in the missing number. That's talking about this right here. I probably should have drawn an arrow to it when I was making this little assessment. This line reminds me of inches, where we have 0 inches to 1 whole inch. We have a half an inch, 1/2, and between a half and between a 0 and half and 1/2 and 1 whole, there are other marks, right? And these other marks, I'll use a different color just to clarify, show how many sections? 1, 2, 3, 4. So these marks right here signify quarters, okay? Because there's now 4 sections, right? Okay. So this would be 1 of 4. And what would this one be right here? It would be 1, 2, 3 fourths, okay? And this line right here goes from 1 to 2, not 0. It's not 0 to 1, but it still shows 1 whole, because from 1 to 2 is 1 whole. Now, what I'm going to do is I'm going to fill in this box with the missing number. Now, each one of these measurements includes the 1 whole, because we are after 1, but there's something missing right here, and that is the fraction 3/4. So this should have been 1 3/4. That is the answer for question number 1. Question number 2. So I completed question number 1. Question number 2. Why does the line plot have mixed numbers, which is a whole number and a fraction, instead of the amounts of money? How come the amounts of money aren't down here? Well, I asked this question and wanted you to use some words here just so that you understood what's going on, because in this lesson 26 from your Ready Math curriculum, it has measurements. We were measuring to the nearest quarter hour, to the nearest quarter inch and to the nearest half inch, right? But now, all of a sudden, we have this money going on. Well, I wanted to use money because with Lemonade and with real world problems, you're going to be running into money. And also, I wanted to segue or transition into teaching money. So that's why I used money. When it comes to money, you have a built-in quarter and a built-in, where's my half? Oh, right next to it. A built-in quarter and a built-in half. 1/4 of a dollar equals 25 cents. 1/2 of a dollar equals 50 cents. Okay? Because a whole dollar, one whole dollar equals, a whole dollar is $1. And you'll never believe what 2 wholes are. 2 wholes are $2, right? Now, how can you put all of that into words? Well, down here, I would write, it says, why does the line plot have mixed numbers instead of amounts of money? If you had all these dollar symbols in there, it could look confusing, the line plot. Also, the fractions are the amount of money or amounts of dollars. It goes from 1 whole dollar to 1 1/4 dollar, which is 1.25, to 1 1/2, which is 1.50, $1.50, to 1 3/4, which is 1.75, and then the line plot ends at $2, written as such, $2. So, how could you explain this in words? The mixed numbers represent amounts of money. And you could include this and are smaller and are smaller. Okay? All I wanted from all of this, from number 2, was for you to recognize that it's the same thing. Many of you wrote under my instruction 1 1/4. Oops. Well, here's 1 1/2. Actually equals 150, and that would really be fine. All right, we did number 1 and we did number 2. It's time for number 3. Number 3 says plot the data on the line plot. Draw an X for each sale of lemonade. Surprisingly, some of you did not do this, even though I told you during the live Zoom exactly how you should. What you should do is simply go through and cross out the amounts as you put X's. So, look, I crossed it out, I put an X. I crossed it out, I put an X. Oh, here's a different one from $1, so I'm going to put an X over here. That's 1.25, which is 1 1/4. Here's 1.50. 1.50 is 1 1/2, so I'm going to put an X here. 1.25, another X over here. $1 again, put an X here. Do you see how this works? You just go methodically through and cross out, put an X. Cross out, put an X. some of you did what I'm doing right now. I made my x's too big, and so I'm putting some next to it. Like I have 2 columns here. Wow, there's a lot of dollars, isn't there? And oh, here's a $2. Put it next over here. That's a big tipper. And then a friend of theirs probably noticed it and did the same thing. Here's 175. Remember, we have 1 3/4 should be written in there. So now I'm going to put an X here. That's the same thing as 1 3/4. 150 goes right here. And 125. Okay, so we should be done. I have every single amount is crossed out. I have all my X's, and I am done with number 3. Number 4, what price was the most popular? Now, in the live Zoom, I mentioned that this is actually asking for the mode, and some of you wrote mode in there as if it were the answer. I wasn't looking for you to write mode in here. I wanted you to actually tell me the price. So what is the mode? Which one of these amounts, this one, this one, this one, this one, or this one, which one had the most X's? Because each X represents one sale. Okay? Well, it's pretty easy to see, and this is where, if you did the line plot correctly, you would clearly recognize that this right here, the $1 amount, was the largest number of sales. So I'm going to put in here the actual price of $1. Some of you just wrote a 1, but the correct answer would be $1. Okay? And I'm going to check it off. I'm done with that one. How many cups were sold for the correct price of $1.25? Okay, that's what the lemonade was going for. And we were trying to sell it for $1.25. So I'm not going to write $1.25 in here. I'm going to look for the sales of $1.25. And I need to identify that $1.25 is 1 1/4, which is right here. And I can see that there are 3 X's, so I'm simply going to write 3 here. Many of you got that one correct. Next, so I'll check that off. Next, how many sales included a tip? So that would be sales that were over $1.25. We're not going to include $1.25. We're only going to mention the ones over it. So that would be not here, but here. Okay? And I can simply count them. 1, 2, 3, 4, 5. The correct answer here would be 5. And I'm done with that one. Now we're going to look at question number 7. I got rid of all the other answers for 1 through 6 so that we were only looking at the data in the line plot in order to answer this. Now, number 7 asks, what fraction of all of the sales were allowed to be under the going rate of 125? So, basically, of all the sales, how many of them were under this 1 1/4? All right. That means that the denominator in this fraction down here is going to be all of the sales. Numerator will be only this. Okay? So the denominator is all of the sales, and the numerator will be $1. So how many $1 are there? There's 1, 2, 3, 4, 5, 6, 7, 8. That's going to be the numerator. So 8. And then how many sales were there in all? So there's 8 $1, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 sales in all. And that's your fraction, 8 over 16. Now, if you know how to reduce fractions and you can figure out equivalent fractions, you should recognize that 8 can go into 16 exactly twice. And that means that 1 8 would go into 16 2 times, and 8/16 is actually equal to 1/2. In other words, if you were really sharp, you may have noticed that half of all the sales were under the suggested price of $1.25. For the very last question on this assessment, I simply wanted you to talk about the information that you discovered through answering the previous questions. I wanted you to explain why you thought that $1.25 was a good price, or why you thought it was a bad price. And you had to use data from the actual line plot, okay? I don't know if you guys know this, but you can put a photo on top of a photo in Sketches School. That's what I did here, just so that I could see the data while talking about and explaining my decision. This could go either way. You could talk about and you could write that you thought no, maybe you didn't think that $1.25 was a good price, and then you should have given an explanation because, sorry, my penmanship is so bad, but because half of all of the sales ended up being less than the price. And if you really wanted to be sharp, you could figure out how much you lost, because, so 8 sales, the 8 sales should have been, how much money did you actually lose? Well, that would be 8/4. And what is 8/4? 8/4 would be $2. So you lost $2 because of those 8 sales. You could have said yes, comma, because even though some people paid less, comma, others paid more. And you could figure out how much more if you looked at these. 2 people paid $1.50. Well, that would be 1/4 more. So 2 people paid an extra 25 cents. 1 person paid an extra 50 cents, and 2 people paid 75 cents extra. Now we have to do a little multiplying in order to calculate this some more, or I could just do repeated addition. This 75 cents times 2 would equal, I'm running out of space here, would equal 150, and then this would was just 50 cents by 1 person, And this was 2 times 25, and that's 50 cents, right? So we've got 50, 50, 50. That's $1.50 plus $1, $2.50, right? $2.50. So the $2.50 is more. Now, I don't know. I'd have to write even smaller to fit this in here, but the $2.50 extra is more than the $2 I lost. And that's pointing to the dollar sales. I hope that this makes sense.